Welcome to the fourth of a 5-video series on algebra basics, order of operations. Here's what's meant by the order of operations. I'm going to pause for a minute, and I'd like you to work out this math problem in your head if you can. Now, there is a valid argument that the result would be 30 or 22. And I'm not asking you to choose which one is right. I'm going to pause again, and what I'd like you to do is I'd like you to make a convincing argument for 30, and I'd like you in your head to make a convincing argument for 22, because they're both valid in some sense. I'm going to proceed. If you need longer to formulate your arguments in your head, go ahead and hit pause. Here's the logic. If a valid argument for 30, or if you got 30 as an answer, you probably added the 2 and the 4 first. 2 plus 4 is 6, and 6 times 5 is 30. There's some validity to that. But on the other hand, if you convinced yourself that 22 is right, it was because you multiplied the 4 and the 5 first. 4 times 5 is 20, and then 2 plus 20 is 22. Now, some of you with an experienced math background are probably thinking that the 22 is right and the 30 is wrong. And while you would be right about that, I'd like to look at this in a broader sense. Let's look at these two problems here. Now, the original problem didn't have parentheses, and these two do. But putting the parentheses in, then the problem on the left is clearly 30, and the problem on the right is clearly 22. But here's what happened with mathematicians. There would be moments where they would put parentheses into a mathematics expression telling you, do this first, work this out, and take the result beyond that in the problem. But there were times where mathematicians would leave off parentheses. And it got very confusing about 5 centuries ago, because when a mathematician wrote the expression you see on the bottom there without parentheses, some mathematicians meant to work it out from left to right in the order they wrote it. And other mathematicians would write expressions like that with the understanding that they were going to do the multiplication first, but there were really no set rules at one point. And it got confusing, and when a mathematician would write this, other mathematicians would read it as 22, and other mathematicians would read it as 30. And so it sort of became understood that unwritten rule from one mathematician to another, hey, if I leave parentheses off, and there's a plus and a times in the same problem, I meant to do the times first. Why is that? Well, it's a long story, but there are some elements of the physical scientific world in which that makes sense, and this is more consistent with the science and engineering of the situation. And for that reason, it just became an understood thing. Multiplication comes before addition. By the way, this rule was not handed down to us on a stone tablet from some mysterious place, that multiplication must come before addition. It's just something that we all started agreeing upon over the centuries, that if we don't have parentheses indicating what to do first, and there happens to be a times and a plus next to each other, that we mean times first. And because this rule, this thing became a tradition over time, it eventually got codified in math as a rule. Multiplication comes before addition in an expression when there are no parentheses indicating what to come first. And because of centuries of tradition and negotiation, this has become sort of a rule now at this point. So you would say that the answer to this math problem is 22. But this brings up a bigger question. What are the other rules and traditions that have arisen over the centuries in terms of subtraction and division and exponents and other things like that? Well, that's what the order of operations refers to. Now it's codified as a set of rules, but it really is a collection of traditions that have developed over time, when we write math problems and there are no parentheses indicating what goes first, what did the author of the problem intend? And that's what this video will discuss, the order of operations. But before we get into the official order of operations, I have to take a brief excursion to remind you what a square root and an absolute value are. This is the radical or square root symbol, and when we put it over a number, we mean that number which, when multiplied by itself, equals 25. So in that sense, the square root of 25, or radical 25, is 5, because 5 times itself is 25. Now this is not specifically an order of operations thing, but it ties in a way that you need to be familiar with that before we can really get started. Secondly, the absolute value is essentially two straight lines, two bars, surrounding a number. The absolute value, you may recall, is the distance from 0 on a number line. So if one were to ask, how far is -3 away from 0 on a number line, we would conclude that it's 3 spaces away. In that sense, when we say the absolute value of -3 is 3, that's what we mean. Essentially, what absolute values tend to do, in a very crude way, is sort of strip the negative sign away from numbers. The absolute value of a positive number, for example, also means the distance from 0. So if we here ask, how far is the number 7 away from 0 on a number line, it's 7 spaces. So in short, absolute values keep positive numbers as themselves, and they turn negative numbers into positive numbers. So now that we've looked at radicals and absolute values, let's get back to the broader picture of the order of operations. So the first thing that we do in the order of operations is anything indicated by any symbols that would tell us or give us a hint about what comes first. Now, to understand what I mean by parentheses and other groupings, I'm going to put up 4 expressions here, 4 math problems if you will, and we're not ready at this point to do these math problems, but I'd like to illustrate some components of them and just ask the question, if presented with any of these, what would be the first thing that you would do? Well, let's start with the problem on the left that says 3 plus 5 times 4 squared. If I were presented with that expression, the first thing I would do is the 3 plus 5. Not because addition necessarily comes first in general, but because it's in parentheses. And anything that's in parentheses is an indication by the author of the problem, the person who wrote the expression, that that portion needs to be worked out first. If you look at the expression with the radical, the first thing I would do here is the 16 plus 9 before I did anything else, before I did the radical or the multiplication by 2. Again, I'm not going to do this problem right now. I'm simply pointing out that even though addition doesn't generally come first in the order of operations, in this problem 16 plus 9 would be the first thing I would do because it's underneath a radical. And there's an understanding that if there's any kind of grouping, a radical being one of them, that we work out what's underneath that first. In this problem here, I would do the 10 minus 2 first. Again, not because subtraction always comes first, but because there's an understanding that if you have a numerator or denominator, in this case denominator of a fraction, that is intended to be done before anything else in the problem. So I would do the 10 minus 2 as my first step on this problem. And in the last one, I would do what's inside of the absolute values, again by the other groupings notion. If we have an absolute value, it's understood that the author intended for us to work out whatever is inside of that absolute value before we proceeded to the absolute value itself or anything beyond the problem. If you'd like to pause, here's the formal definition of what other groupings might be. The square root and absolute values just being examples of something that in more general could be any functions that you'll discover in higher algebra. So there's this understanding, especially in the beginning of algebra, if any of these 4 situations arise, parentheses, numerator or denominator of a fraction, radicals, or absolute values, that we start our order of operations there because that's what the author of the problem intended for us to do. So, other than these four situations, what if sprinkled throughout the problem we have addition or subtraction or multiplication or division or even exponents in the problem as well? How do those rank? Well, mathematicians could have decided anything, but historically it developed over the centuries an understanding among mathematicians that this would be the prioritization, the order in which we do the mathematical operations. You may even be familiar with the phrase PEMDAS, which is almost synonymous with the order of operations, and you can see where that phrase came from here, PEMDAS. There are some flaws in that acronym, if you will, and I'd like to reveal those to you now before we start looking at examples. So let's start with multiplication and division. Which comes first, multiplication or division? Well, in the list, multiplication comes first, but I'd like to compare two problems. Here's a problem that has both multiplication and division in it, and here's another expression that has almost the same symbols in virtually the same order here, but a slight difference. Let's look at the one on the left first. Now this division symbol right here is the division symbol being referred to in PEMDAS, and when you have multiplication and division in the same problem, there's an understanding that the author intended you to work from left to right. So it's not that multiplication comes before division or that it comes after, but if they're both in the same problem, the priority is left to right. So looking at this expression, the first thing I would do is 24 times 10, not because times comes before divide here, but because it came before divide in this particular case, left to right. Then I would do 240 divided by 5 next, because that's what comes next in left to right order. If you worked it out on scratch paper, 240 divided by 5 does work out to 48. Take my word for that. And finally, I'm going back to multiplication as I work from left to right. 48 times 3 is 144. Again, some work on scratch paper would prove that to you. Now, let's compare the division problem on the left to the division problem on the right, where here the fraction symbol is used as division instead. Now, in this particular case, because I have a numerator and denominator of a fraction, this is not the division being referred to in PEMDAS. This falls under the category of other groupings. In other words, in this problem, even though that is a division, I don't wait till later to do that. I immediately, because of our rules, I immediately do 24 times 10 as one problem, work out the numerator, and then 5 times 3, which is 15, and work out the denominator. So the reason I did multiplication before division in this case is not because multiplication comes before division in PEMDAS, but because this kind of division, the fraction division, falls under the category of other grouping. In other words, I have to work out the top and bottom before I do anything else outside or within that problem. Now, if you were to use scratch paper and do 240 divided by 15 and do some long division on paper, it would eventually work out to 16. And you can see how two similar problems have different answers. But let's focus back on the left. See the division on the problem on the left? That is not a division symbol that we use in algebra courses or higher. It's extremely rare. It's really reserved more for elementary and middle school mathematics. So because we don't use that division symbol, then the whole notion of left to right between multiplication and division doesn't matter to us. In fact, the whole division word itself from PEMDAS isn't really relevant in an algebra class because we don't see that division symbol used in our expressions. So for our purposes, we can take division right out of the order of operations because when we do see it, it will be like the problems on the right, where we have to work out the numerator and denominator first. Okay. Now I'd like to compare addition and subtraction. Here's a problem that has both addition and subtraction in it. Now yes, addition comes before subtraction in the phrase PEMDAS, but that doesn't mean we do addition before subtraction or subtraction before addition for that matter. The rule there is also work them out from left to right. So in this particular problem, I'm going to do the subtraction first, not because subtraction always comes first, but because it does in this problem. So 5 minus 15. 5 minus 15 is negative 10. Now I'm going to continue simplifying this expression left to right by ignoring the plus 1 and just doing negative 10 plus 3. Negative 10 plus 3 is negative 7. And finally, negative 7 plus 1 is negative 6. And that's the simplified version of addition and subtraction problem. However, I don't like to have addition or subtraction listed in my order of operations because in essence they're really the same step. In fact, the higher we go in algebra, the less we use words like addition and subtraction. Here's a word we're going to use from now on when we're referring to the addition and subtraction step. We'll use the word to combine. Combining is the act of adding and subtracting terms, and so I like to consider that my last step in the order of operations. Just going to move that up for space economy. And now, even though we traditionally hear the phrase PEMDAS when it comes to our order of operations, when you're in an algebra class or higher, we really don't use that phrase so much anymore, and we really have our order of operations boiled down to these 4 steps. And now we can begin to look at specific examples. So let's look at our first actual example of how to apply this order of operations to a specific expression or problem. Okay, looking at this problem, we see lots of operations. We see an exponent, there's clearly addition and subtraction, and we have a fraction. Well, in our first step, you'll see at the top of the screen, parentheses and other groupings. There may not be any parentheses, but the fraction counts as an other grouping. So we've got to work out the fraction first. So the first thing I'm going to do is the numerator of that fraction, 3 minus 24. There's the result I got for the numerator. Substitute that in. Next, to finish the fraction, negative 21 divided by 7 works out to negative 3. There we have that. Notice I'm subtracting a negative 3. That's the same as addition. I technically went a little bit out of the order of operations here because I'm jumping down to step 4, but that would have eventually turned into a plus 3, so no harm done. Now looking back at our order of operations, we're done with the other groupings, which in this case was a fraction, and now we've got to work out our exponents. Well, our exponent is 5 squared. 5 squared is, of course, 25. There's that change. Now if you look next in the list, there's multiplication is the next item, but we don't have any. So moving to our last step, combining, that requires us to work from left to right. So the first thing I'm going to do is the negative 4 plus 25. That works out to 21. And finally, that ultimately simplifies to 24. And that ends our first of 3 examples. Here's another example. Let's check this one out. You'll notice we have addition, subtraction, multiplication, and exponents here. By the way, do you see the hidden multiplication? It's right there between the 2 and the parentheses. So looking at our order of operations at the top, parentheses and other groupings, well, we actually have parentheses here, so I'll do those first, or what's inside them anyways. 7 minus 10 is negative 3, so I can make that change. Then, looking at our order of operations, since I've done what's inside the parentheses, I'm going to move on to our next step, exponents. We have an exponent above the negative 3. Negative 3 squared is positive 9. so I can make that change. Now I'm done with the exponent portion of my order of operations. Looking at the top of your screen, you'll notice multiplication is next. Now the dot that you see as a multiplication sign wasn't in the prior steps, but it was implied by the fact that there was a number next to the parentheses and no operation listed in between them. Why did I put the dot in the bottom line here? Well, if I didn't put the times sign dot there, you would think that was a 29 as opposed to a 2 times 9. Okay, doing the multiplication, 2 times 9 is 18. That allows that change. And now that I'm down to my fourth step, the combining step, I'll again work left to right. Starting on the left, negative 2 minus 5 is negative 7. And finally, negative 7 plus 18 is positive 11, or just 11. Here's our third and final example. There's a lot going on in this problem. You'll notice we have addition, subtraction, multiplication, we've got the fraction, division, and we've got a radical. So there's a lot to do here. Well, step one is parentheses and other groupings. Well, we've got a fraction to work out, but you'll notice the top and bottom of that fraction are almost like their own math problems. So you see the 1 plus on the left side? Before I can add 1 to this fraction, I have to figure out the value of the fraction. That means I have to work out the numerator and I have to work out the denominator. I'm going to work out both. First, let's work out the numerator. It doesn't matter which one you start with, so I'll start there. Now in that numerator, I have a minus and a times. Times comes before minus there, so I'm going to do the 5 times 7 part first. Notice I'm still working out the numerator here. Okay, in the numerator, which still isn't worked out, 3 minus 35 is negative 32. I can now make that change. Okay, next, now that I've worked out the numerator completely, I'm still not done with my fraction. I still have to work out the denominator. Well, in the denominator, you'll notice I have a radical, but I also have a times. You see the 2 in front of the radical? That means 2 times the result of that radical. We don't see the times sign there, but because the 2 is sitting next to it with no operation in between, multiplication is assumed. But I have to work out what's under the radical first. Remember, what's under the radical first has priority in that denominator. So I'm just going to work out the 16 plus 9 part and make that change. Then I'm going to work out the radical 25. Radical 25 is 5, allowing me to make that change. Now notice the dot I've put there as a multiplication. That dot wasn't there before, but it was implied by the 2 being next to the radical. I have to put the dot there now, or you'd think I meant 25. Of course, now I'll do an easy part. 2 times 5 is 10. The point being, if you look back above the work, and you may want to pause here for a minute after I make this comment, the big picture here is that I had a fraction, and in the top and bottom of that fraction, I had a lot of operations to do. So I essentially worked out the top as if it was its own math problem, and then worked out the bottom as if it were its own math problem. And now I'm ready to do the division. If you're a little lost on all the numbers, you may want to pause and review everything before we go on. Okay, let's proceed now by finishing the fraction by doing the division. Negative 32 divided by 10. Now on a calculator, that would give us a decimal. In fact, it would give us negative 3.2. However, we don't use decimals in algebra, except in very rare cases. And so I've got to think of how to do negative 32 divided by 10 in an algebra context. Well, in an algebra context, the only thing I can do to that is reduce it. 32 tenths reduces to 16 fifths. So I'll make that change here. And now I have done the division problem as far as it can go. Now, of course, a calculator could take this further. 16 divided by 5 on a calculator would again give you 3.2, but that's not our focus in an algebra class. In an algebra class, we have to look at this as a common denominator problem. So what I'm going to do with my 1, I'm going to think of it as 1 over 1. And then, notice I don't have matching denominators unless I multiply by 5/5. And now I have matching denominators. And as is always the case, once your denominators match, you keep that denominator the same, and you simply work out the numerators. So now I'm going to do 5 plus negative 16. That works out to negative 11. And that is our final result. And that completes the fourth of this 5-lesson series on basic algebra.